The electroencephalogram, EEG, is a recording made from the scalp of the brain's electrical activity. The objective of this study to develop a VIG data acquisition for medical application using MATLAB. In this project, using a medical application to detect epilepsy that is usually not detected in the early stages and is only detected when the patient has had a seizure because the seizure detection test requires a high cost. Determine which kind of input data should be used to explore epilepsy seizures detection and achieve the best results for use with a neural network. Also to test and compare real brainwave data, obtained from IIDEX sensor by using artificial neural network, ANN. Using Bonn University dataset. By using hardware such as MindLink IIDEX sensor, Bluetooth module and Arduino Uno as a medium to take data from the patient's brain and send it to MATLAB software to analyze and get answers. In MATLAB software, the neural network train and test programs were developed to carry out operations using pattern net neuron value 25 after the experiment was conducted and found that this neuron value 25 can produce an accuracy of 83%, which will produce an artificial neural network, ANN. As a function test for assessing how well a trained ANN performs on a collection of test data. GOA, graphical user interface, in MATLAB are helpful for developing interactive tools, and data visualization has been developed to make it easier for users to use the test program. As a result, a variety of methods for recording these signals and directly visualizing the graphs using the software have been created, which may then be assessed by a professional, and some observations on the functioning of the brain made. As a result, the following is the project's goal. 1. To develop VIG data acquisition for medical application using MATLAB. 2. To determine which kind of input data should be used to explore epilepsy seizures detection and achieve the best results for use with a neural network. 3. To test and compare real brainwave data, obtained from IIDEX sensor by using artificial neural network, ANN, using dataset University Bonn. Hardware development refers to three main components consisting of IIDEX sensor, Bluetooth module and Arduino Uno, which are combined to send and receive signals from the patient. 1. A tool used to assess brain activity is called a MindLink IIDEX sensor. Electroencephalography, or EEG, is a method that measures the electrical activity of the brain by attaching electrodes to the scalp. The electrical activity of the brain is detected and measured by these sensors, which then translate the data into a digital signal that can be processed by specialist software. 2. A Bluetooth module is a tiny electronic gadget that enables Bluetooth-enabled wireless communication between devices. 3. In order to make a connection between the Arduino and the Bluetooth module, the necessary hardware such as the Arduino board, the Bluetooth module and the USB cable to connect the Arduino to the computer. 4. All parts of the project will be put into a hard case carrier to maintain safety and avoid damage caused by falling or flooding. Among other reasons is the use of a hard case carrier to make it easier to carry this product, in addition to being an added value for cosmetic appearance. Software development is divided into two types of software, which is the Arduino, which needs to be used to make coding for hardware such as Arduino Uno and Bluetooth module so that it can work as planned. The second software is MATLAB software, which is used to analyze the entire project, including two codings for training and testing. Graphical user interface, which is a type of user interface that allows users to interact with a computer. The pattern net function in MATLAB is a tool for building feed-forward neural networks for jobs requiring pattern recognition. A feed-forward neural network is a kind of artificial neural network in which data only flows from input to output in one direction, never looping back. The standard deviation in MATLAB is an indicator of a dataset's variability. The MATLAB environment's built-in std function can be used to calculate it. The University of Bonn in Germany assembled a publicly accessible dataset called the Bonn Epilepsy Dataset. The part of an EEG dataset used to train a machine learning model is often referred to as the train section of the dataset. The results found that normal and abnormal results were successfully displayed on the GUI software, which took 20.86 seconds for 20 data, 50.73 seconds for 50 data, 1.42 minutes for 100 data, 17.10 minutes for 1000 data, 51.18 minutes for 3000 data, and 4097 data took 67.18 minutes. From the resulting graph, it can be converted to a voltage value so that it is easy to make a comparison with the dataset from the University of Bonn to get the results of whether the patient tested is normal or abnormal by simply pressing the test button. A normal result indicates that the tested patient is normal with just less than 2 seconds.